Hi everyone, and welcome to this demonstration of CapyMOA, an open source platform designed for machine learning on data streams. This presentation is part of the ECML PKDD 2025 demo track. Over the next few minutes, I will introduce CapyMOA's key features and show you how easy it is to build end-to-end stream processing pipelines. In real-world applications like fraud detection, network monitoring, or wearable sensor analysis, data doesn't arrive in fixed-size batches. It comes continuously, often with shifting patterns, known as concept drifts. CapyMOA addresses this challenge by bridging the robust MOA framework in Java with flexible Python interfaces, allowing you to easily build, test, and evaluate adaptive models on streaming data. Now, let's dive into the notebook. First, we use the drift stream interface to simulate a stream with both abrupt and gradual drifts based on the SEA generator. Next, we showcase CapyMOA's high-level evaluation functions, starting with frequential evaluation. Here we introduce KNN and Hoisting tree algorithms to evaluate them on the drifted stream. CapyMOA automatically collects both cumulative and windowed results. Cumulative results are displayed here, and we will explore window results shortly. CapyMOA also supports automated machine learning for data streams. By reading a simple JSON file, you can specify inner models and their parameter ranges, and CapyMOA will automatically optimize them during training. Another powerful feature is the streaming learning pipeline. In our example, we built a pipeline with a normalization layer, a classifier, and a drift detector, all configured in just a few lines. While cumulative metrics are straightforward, windowed metrics are more complex as they are a series of values. CapyMOA provides built-in plotting functions to address this. Simply pass in your results and select a metric, and the plot is generated for you. And the information about the concept drifts will also be marked in the plots. Beyond supervised learning, CapyMOA also supports semi-supervised learning. You can adjust the label availability rate easily and plot the results just like the supervised models. CapyMOA also includes unsupervised learning capabilities. It offers various clustering algorithms, high-level evaluation functions, and even GIF-based visualizations, showing how cluster evolves over time, helping you truly understand the clustering process. For anomaly detection, we first simulate a 2D dataset and evaluate different models using CapyMOA's specialized high-level evaluation functions. Again, we visualize model performance over time by plotting AUC scores. Recently, CapyMOA expanded to support online continual learning, which combines stream learning and continual learning. We provide ready-to-use datasets, algorithms, and evaluation tools for this emerging area. We also cover the regression side of supervised learning. Here, we employ a multiple learner evaluation function, which outputs a dictionary of results, making comparison easier. CapyMOA also supports prediction interval tasks, where models predict intervals instead of single values. CapyMOA not only plots the usual windowed metrics, but also visualizes the predicted intervals against ground truth over time. This is the end of the notebook. This notebook will also be published shortly for you to explore. You will find references to all the materials mentioned at the end. CapyMOA is developed by our teams, led by Hater Gomez, with support from many advisors and contributors along the way. For more tutorials, examples, and documentation, please visit our website. Thank you for watching.